All right, friends, we're going to do section 3.3. And this is all about function notation. Wow, I just used another one of my words, didn't I? I did, didn't I? So I better get my highlighter out because I used one of my vocab terms, function. Okay, so we're going to learn about function notation. Hey, friends, I'll give you a hint. It's just f of x. Okay, and we're going to talk about how to use it to solve and graph and do some real life problems. So right away, I want you to know that as a linear equation, oh, I just used another vocab term. A linear equation would be y is equal to mx plus b. Okay. If I want to write it in function notation, all I'm going to do is replace that y with f of x. Okay? See that? No big deal. So this says, this is really read as f is a function of x. So whatever I plug into x, that's really what y is ending up being. So if f is a function, then x, this is the domain, right? Another vocab term, okay? And this piece then is the range, it's the y value, and it's your output, right? The domain is the x, this is my input, and that's my output. So you see how those vocab terms fit together? Okay. All right. So my first set of things that I'm going to work on is evaluating. So that's a great word. So evaluate. Evaluate just means to plug something in and calculate it. Okay. Plug something in and calculate it. So we're going to evaluate f of x is equal to negative 4x plus 7. And I want you to evaluate it when x is 2 and when x is a negative 2. So here's what you do, okay? I have f of x. So what you're saying is I want to find out when x is 2, okay, what happens? Now, do you see how I said this? When f is 2, I am not calculating this. I'm finding out when f is 2, okay? So I'm going to take this and I'm going to plug in that 2 in for x, and I'm going to calculate it. Negative 4 times 2 is negative 8. See, this is where order of operations really takes place. And my answer here is negative 1. So when x is 2, okay, f of x is a negative 1. Okay, did you see how I just wrote that? Or I could even write it as a ordered pair, couldn't I? When x is 2, y is a negative 1. Let's try this negative 2. So f of negative 2, same thing. Negative 4 times negative 2 plus 7. This doesn't change. What's negative 4 times a negative 2? Well, that's 8. And what's 8 plus 7? Well, that's 15. So I could write this, let's just skip. So when x is negative 2, f of x is 15, or I can write this negative 2, 15. Now stop and think about it. Which one's an easier one to write? Absolutely. Okay? Absolutely. Okay, questions on that piece? Okay, now it's your turn to practice. This is going to take us a couple of pages. There's a lot of stuff, so you practice. here we go. F of x is equal to, I'm going to go 2x minus 5. Okay, and I want you to evaluate when x is -4, 0, and 3. Okay, this is the part where you want to stop the video so that you can practice this. Okay, and then you can start it up when you're ready. So I'm going to take a -4 here. Here's the thing, I'm probably going to ask you some questions along the way. So I'm going to take that -4, this is the -8 minus 5, and f of -4 is -13. I'm going to go ahead and write that, -4, -13. All right, my next one, f of 0. Oh, I love plugging 0 in. So easy. Because 0 times anything is just 0. It's the easiest one to do. So when x is 0, f of x is -5. All right, my last one, f of 3. So f of 3 equals 6 minus 5, and f of 3 equals 1. So my answer is when x is 3, f of x is 1. Awesome. Okay, we're going to keep going on the back, and we want to use function notation to kind of do some interpretation. Okay, so in order to do that, I'm going to kind of share with you a story, okay? And, okay, so I'll write it down if you want to write it down with me. So I'm going to say let f of t be the outside temperature in degrees Fahrenheit, okay? T hours after 6 a.m. Okay, and we're going to explain the meaning of each statement. So here we go. All right, so I know this looks really confusing, but let's really break this apart. Are you ready? I'm going to use my markers to kind of, okay. So let's look at this. Let's look at this T. T hours. Okay, T hours. T. So T stands for hours, right? Okay, and so what does the combination of F of T stand for altogether? What's the function of T? It would be the outside temperature. So F of T is temp, okay? All right. So let's take a look at this. So T is right here. Well, what's 0 hours T? Well, what's the beginning of this graph? Wait a minute. The beginning is 6 a.m. So at 6 a.m., this whole piece is equal to what? 58. 58 what? 58 degrees Fahrenheit. So at 6 a.m., it's 58 degrees Fahrenheit outside. Okay. All right, so what in the world does this mean? 6 what? 6 hours after what? Hour 6 after 6 a.m. 6, 7, 8, 9, 10, 11. Oh, that's noon. Oh, so at noon, wow, that doesn't make a whole lot of sense, but we'll count it. At noon, our temperature is N degrees Fahrenheit. Huh, because it gives me an N. So 6 is 6 hours after 6 a.m. All right, I like this one. All right, 3 hours. Okay, so what time is it? 3 hours after 6 a.m. 7 a.m., 8 a.m., 9 a.m. So the temperature at 9 a.m. is less than or colder than, wow, what would it be 9 hours? Wow, from 6 o'clock, well, let's see, 6 hours was at noon, that's 3 more hours, that's 3 p.m., isn't it? Now, let's stop and think. Will the temperature probably be warmer at 3 p.m. than it is at 9 a.m.? More than likely, yes. Okay, so see how you can take the function of something and how those pieces work together. Okay. So looking for that inner meaning is really, really super important. So how can we take what we have here for these values, and how can we solve for these items? How can we go backwards, and how can we graph? Okay. The first thing I want to do though is practice solving. We solved for the dependent variable, so when you plugged in for x, wonder if you're given something a little bit different. So let's do this. So solving for the independent variable. So for h of x, see, it doesn't matter. You can use h of x, you don't have to use f of x. Find the value of x, yikes, for which h of x is -7. Whoa, hold on. So you remember, so here's my x, okay? But h of x is negative. So I'm not plugging in for x now. I'm plugging in for h of x, which looks different than what we had here. So let me go back to the front. See how this was an x? This is telling you, hey, here's y, now solve for x. So what we're gonna do is we're gonna take the -7 and we're gonna replace it into the equation like this, okay? And now we're going to solve for x, which means get x all by itself, which means, friends, that you can totally do this because you are onion masters and can do this. So let's add 5 to each side. So -2 equals 2/3 x. Divide by 2/3, which is the same as multiplying by the reciprocal, which is a -3. Now, how do I write that? Well, in an ordered pair, I always write my x first, okay? Then I write my h of x, or my y value, is a -7. Okay, so that's how it would show up. So you just got to be aware of that sometimes that can happen. All right, now you practice, okay? You practice, and then we're going to do a quick graph. F of x is equal to 6x plus 9, and I want you to find x when f of x is 21. Okay, So again, I want you to, this doesn't say x equals 21, this says f of x equals 21. So plug that in for your f of x. 21 equals 6x plus 9. Onion that bugger up. You've got this. Minus 9 is 12. Divide by 6. And x is 2. Write it as an ordered pair, please. X and y. Very good. Okay, so now we're going to take these same things and we are going to graph. So the next piece that we're going to do, actually, I'm going to do a new video and we're going to work on just graphing.